So we're given that T is a linear transformation that takes P3 to P2, and it's defined by just taking the derivative of the polynomial that's given. So B and B prime are the respective bases for P3 and P2, and we are to find the matrix of T relative to B and B prime. So we're just going to start by remembering that A is just equal to T of the basis vectors, and then written in terms of the basis B prime. So T of x cubed, T of x squared plus x, T of x plus 1, and T of 1. And again, because each one has to be in terms of the basis B prime, we're just going to use the notation that explains that that's what we're getting. And then A itself is a matrix. So we're just going to compute the columns of A. So T of x cubed is the derivative of x cubed, so it's just 3x squared. And then in terms of the matrix B prime, we see that the coefficient in front of x squared is 3. So the first coordinate is 3, and then the other two are 0, because that's the only term there was. Then we just repeat. So for the next basis vector, we have T of x squared plus x, and that is the derivative, so it's 2x plus 1. And then we just remember in terms of the basis B prime, we need to find the coordinates. So this one you could probably do in your head, but it's a little trickier because B prime isn't the standard basis. So what we want to do is we want to rewrite 2x plus 1 as a linear combination of the basis vectors of B prime. So it's r1 x squared plus r2 x plus 1 plus r3 times 1, and r1, r2, and r3 are just scalars or real numbers. So to figure out what these are, we just notice there's no x squared term on the left, so r1 has to be 0. And then on the left, the coefficient of x is 2, so we see that the coefficient of x on the right is r2, so r2 has to equal 2. And then on the right, we have that the constant term is r2 plus r3, and on the left, that's equal to 1. So if we substitute, we just see that r3 is equal to 2, 1 minus r2, so it's negative 1. So then the second column of A is equal to r1, which is 0, r2, which is 2, and r3, which is negative 1. Okay, then we're getting close to being done. So T of x plus 1 is the derivative of x plus 1, which is just 1. So in terms of the basis B prime, that is just equal to 0. There's no x squared term. 0 and 1. And so then we have T of 1 is equal to 0. So in terms of the basis B prime, that's just equal to 0, 0, 0. So this tells us that our matrix A is equal to those columns. So we have 3, 0, 0, 0, 2, negative 1, 0, 0, 1, and 0, 0, 0. So 4 columns, 3 rows, which makes sense because we're mapping a 4-dimensional space to a 3-dimensional space.